So I'm going to be talking about long distance trip modeling using StreetLight data. These are long distance trips, and so we use the home location as a surrogate for the far trip end instead of an OD. So this is not an OD. This is a home location, and so we're thankful for being able to do that. So I'll jump into it. The situation is that we have these candidate, what we're calling gateway projects, because they're out on the edge of our region. And we got 4 of them there in gray, and notice that 2 of them are conversion to interstate. And so I was interested in interstate versus non-interstate. Notice also in the note, it says that of the top 50 US metros in America, Hampton Roads is the only one in America with only one interstate radius. And what I mean by radius is starting in the center and going out. And so, for example, for Richmond, you have 4 of those. You have 95 north, 95 south, 64 east, and 64 west. And so we're interested in interstates. And so the goal is to prioritize these 4 projects based on how well they connect us to the rest of the world. So the general method that I was using is to prepare a long distance trip model, which I don't want to scare you. It's just an equation, okay? Just a simple equation that explains the number of trips between external areas in Hampton Roads. And as you might imagine, it would be based on the population of those areas and the travel time to those areas. So, for example, between here and Richmond is a fairly big place and it's fairly close. So we have a lot of trips between here and Richmond, whereas, say, here in Atlanta's a huge place, but it's a long way away. And so we don't have a lot of trips between those 2. And then take something really close. I don't know. I'm trying to think of a little place, Dumfries or something. Actually, Dumfries has become a pretty big place. But anyway, just think of a little town outside of, I don't know, Charlottesville or somewhere. So we don't have a lot of interaction with them, even though they're close because they're small. Okay, so then we can plug the projects into that equation and see what the change in travel time, for example, does to interaction between us and the other areas. Okay, so one of the main things in this today is does interstate status impact this connectivity? And so I had this theory that it did, and so then we wanted to test it, and we used StreetLight data to test it. And I called it the qualitative interstate effect, because interstates have these qualitative attributes. In addition to their, for example, speeds, travel times, they have these qualitative things that are a little harder to measure, but thinking they might be significant. And that's, they have rest areas, they don't have any traffic signals, they are, have wide design and gentle slopes and clear signage that's essentially the same all over the country. So it's like it's a standard. It's like McDonald's. You know what you're going to get when you go there. And they have, I believe, they have higher safety than other highways. So the theory then would be that all other things being equal, that more trips would be made between 2 metros that are joined by interstates than between 2 metros that are joined by non-interstates. So we wanted to use StreetLight to test that. And in these models, these simple equations, if that is true, then the interstate travel time coefficient will have a lower coefficient. It'll be less onerous, in other words, when you're looking at the number of trips between areas. Okay, so this is the way we set up the research. I won't go into too many details, but we prepared two sets of metro pairs, an interstate regression and a non-interstate regression. And again, regression, not to scare you, it's just taking data and then plugging it into the computer and coming out with an equation that explains that data. That's all regression is. And so anyway, then we're going to compare those 2 coefficients and see if there is such a thing as this qualitative interstate effect. And by the way, we think we're the first to do this. And for one thing, most people don't have access to this kind of data. We haven't in the past had access to this kind of data to be grainy enough to be accurate enough to measure these kind of subtle effects. And so in the second half of the slide there, we randomly selected 10 destination metros, and these were outside of Virginia. So we gathered pairs for those 10, and I'll show you that. And then we separated them into two groups, the interstate, the ones that are joined by interstates and the ones that are joined by non-interstates. So how did we get the data? Well, the trips between the areas came from StreetLight, and then the highway type and travel times came from Google Maps, and then the population came from the census. So here's what the data looked like. You can see in the first column the 10 destinations, and those were just randomly selected: Seattle, Denver, Toledo, and then for each one, several other ends of the trip. So for Seattle, you got Portland, Yakima, Helensburgh, etc. So we're interested in the population of both those areas, and then the third red circle is for the trips that were calculated from the StreetLight output, and then the last column being the travel time that I got from Google Maps. Okay, so then when you plug that in, 58 records, you get a real good R squared, if you're familiar with that, 0.86. 1 is the highest you can get. And so there's our coefficient, 90. Okay, so remember that when we go to the next one, which is the non-interstate, and we had a little lower R squared, but notice that our coefficient is almost the same at 92. And so there's not a statistical significantly difference between 90 and 92, as it turns out. And so we conclude, somewhat sadly, I guess, no evidence of a qualitative interstate effect. In other words, interstates are great for a lot of things, like I said, safety and that kind of thing. But apparently, all other things being equal, they don't join the metros any better than a non-interstate with the same travel time would join them. So then we're back to, okay, we need to test these projects. So what do? Well, we just prepared an equation that simply explains trips based on population and travel time and not on highway type. And so I'm going to show you how we did that, and it gets into some of the details of StreetLight. So again, we're getting the trips. This time we just did it with the Virginia license, because we were just doing Hampton Roads, and we were just basing it on Hampton Roads. Now you'll see that my externals are outside the state, but I can do that because when you're using home location, it gives you the home location regardless of where it is. It could be, I mean, I don't know that it can be in England, but I mean, it can be all over the US, the home locations. So same sources, Google Maps, StreetLight, and Census. Okay, so a little bit of details for you StreetLight users. Zone creation, there's my zone. And it's the whole region. Okay, and just a little in the weeds. I mean, it's bigger than the standard StreetLight zone, so they have to they have to push a special button to allow it to go through. All right, so then what am I doing? I'm doing a zone activity analysis. Like I said, it's not an OD analysis, it's zone activity. And so you select that, you select all vehicles, and then it asks you what kind of zone do you want to choose. And I was sort of confused because I've got my zone. It's not any of these three. So I just hit next. And then it says, where are the zones you're looking for? And I'm not. So I just hit get started. And then I get the chance to choose from user-generated zone sets. And so I did. I selected my zone that I'd drawn there in blue. And then I chose a whole year's worth of data, which is great because you get this huge sample size. And that's an output that StreetLight gives you. They let you know how big the sample size is. So you can get a feel for how accurate the results are. And here, over 1 million devices that were tagged and over 83 million trips. So I feel really good about it. And then just a little bit in the weeds, but this is important because the reason we used this home location was because, well, 2 reasons. One, because they're outside the state, but a lot of them. But 2, StreetLight ends a trip if the phone is stationary for 5 minutes, and that makes sense when you're talking about shorter distance trips. But when you're talking about longer distance trips, you're going to stop at a gas station and that kind of thing. And so that's why we use the home location, in this case of visitors. And StreetLight defines visitors as people who live outside your zone, I believe. So, and if you want to get that data, you check the home and work locations, home and work metrics, and then you tell it which ones. And I just got the first one, which is the visitors, so not the residents or the workers, which are the next 2. And then this is what the output looks like it's called a metro area file, home metro area file. And you can see in my column G, I guess it is, that the name of the external metro, so Richmond, Washington, New York. And I have just, multiplied the 2 StreetLight numbers, the percent and the total volume to get the trips. So this is what it looks like when you map those trips. So not surprisingly, like I said, Hampton Roads there in red at the right side of the map. A lot of trips to Richmond and Washington, as you would expect, and then a few to Charlottesville and Lynchburg. But they're smaller and they're farther away. And then in North Carolina, Elizabeth City, a lot there, but because it's close. And then Raleigh, a fair number because it's big and it's a medium distance away. So you take that data, which is in that first column, the trips column, and then the population, and then the travel time to those areas, and you plug it into the regression. And this is what you get. You get a great R squared again, and you get this coefficient. And this time we're not comparing coefficients, we're just making an equation out of it. So for us, trips from Hampton Roads equals the population of the external area divided by this coefficient times travel time and squared. And I'm not going to go into why it's squared, but trust me, it is. Okay. Then lastly, this is an example where we plugged the travel time savings of one project, which would be an improvement of US 58, and then seeing, doing with and without, and seeing the additional trips with this reduced travel time. And so not surprisingly, you got these additional trips in Western Virginia and in North Carolina, because this is what the highway serves. And, the biggest circles being the biggest and closest areas. So Raleigh and Charlotte and that kind of thing.